Well, hey there again, everybody. This is Bob from Hot Rock Central, and today I'm going to be taking you through my solar water heating system. And what you're looking at there is my spring, summer, and fall heater, and I've got another one around the corner here, which is my winter water heater. Now, during the winter time, both of these are running together, but they're independent of each other. So while one or the other isn't really good enough to give me sufficient hot water, the both of them working together does pretty good. Now, both of them are using PEX pipe, and this particular one here, I'm using Durarock or cement board for the backing. And the reason for that is, although it's pretty darn heavy, it's an excellent heat sink. So as you're sucking the cold water out of the water heater, and it's going through the coil and going through another cycle, you've already got stored up heat that's been collected in the cement board that's being transferred into the coil. So it takes less time for the coil to heat up and do a cycle. Now, this particular one here, unlike the other one over here, which is stationary, this is on a hinge, and it's moved with this winch over here, which goes up to that cable there, up to that hoist, and back down to the collector. And one of the things you have to deal with when you build this thing is you got to put some kind of freeze protection on it. You got to be able to drain it during the winter time. So let me get this up in the air and show you what I did here. And this sucker probably weighs near about 200 pounds. A lot of it's from the glass and the rest of it from the cement board. The rest of it's not all that heavy. So I got plenty of heavy duty hinges there to hold this thing up here. Now, there's a drain cock for that, and being that this thing has a pretty good angle to it, that'll make it drain pretty good, but not without something else. You also have to have some drain cocks on the pipes going into the shed, because what you're going to have is opening that alone is not going to drain it completely, because there's a vacuum on the system. So to break the vacuum, you got to have some drain cocks there to allow the air to move the water through the system. So there's drain cocks on each heater. Now, to make them even more efficient, I had to protect the back sides of both of these with some insulation. So I've got foam board on that, and then I've got a piece of plywood over the back of the foam board there. So that helps keep some of the heat in. Now we'll go into the shed. Oh, wait a minute. Something else I want to go back to this one here. Now the winter heater, if you can see that okay, is broken up into two coil sections. And there's a reason for that. For this to be drained during the winter time, you have to have a pitch on the pipes, a downward tilt going to the bottom on each leg. And if you were to make a run completely from one side to the other, there would be such a steep pitch from end to end that you would lose quite a bit of coil capacity. So by breaking it up in two, that solved that problem, gave me more coil surface. And then right there is the pickup sensor, which is the outgoing line that goes into the water heater. And then there's the incoming line, which sends the water through this coil here, down there that way, then across this one, back up, and then finally out. And being this is stationary, this one will only work well during the winter time, because during the summertime the sun is almost straight above. So sun coming down straight down is not going to get in there and do anything. But during the winter time, that tree there in the back, the sun is probably about 10 degrees above that in the wintertime. So it's almost making a direct shot right into the cabinet. So it does a really good job during the wintertime, where during summertime it won't do crap. But now this one here, because of the pitch that it's got on it and the angle, it doesn't do very well during the wintertime. It does okay, but not well enough to work on its own. So with the two of these combined, I can get a pretty decent amount of hot water during the wintertime. Whereas this one right here, this thing is bodacious in the summertime, man. I'm getting water heater temperatures of 150 degrees in my tank by the end of the day. Okay, I think we're through out here. Now I'll take you inside and show you all the other stuff that makes this thing work. And there are the thermostats. There's the one for the summer water heater, and that's the one for the wintertime. Oh, the winter's not being used right now. I just leave it on. It just kind of like seeing the cabinet temperature in there. It tells me what the cabinet temperature is. And then this one here that's not on is actually part of the summer system. And what it does is in the morning, when the sun doesn't have the intensity like it does in the afternoon, it'll kickstart the system by sending in less hot water, or the not as hot water during the morning to get it the water heater kick-started. And then say about 10 or 11, depending on the time of year, this timer right here, we'll switch it over to this one, and this one will be set at 150 degrees, and there's a 10-degree difference between it shutting off and shutting on. So at 150, set it at 150 degrees, it'll turn on at 160 and cut back off at 150. And then on top of that, when both of them are working together, I don't want them both working at the same time. So I had to put a relay in there to differentiate between which one will run and which one won't. So say, for example, if the thermostat calls for the winter water heater, that overrides this one, shuts it off, shuts off the pump to that. If it was running, it would shut it off, and this would take priority. Then once it's done with that, then it would turn this back on, let it finish up its job. So that's a pretty neat little trick there. Now, one of the other things that's nice to have on a system like this is a sensor on your water heater. So what I did is I took two sensors and put one on the top of the tank and one on the bottom. That way I could look and see what my upper and lower tank temperatures are. And right now we're on the lower, and switch to the upper, and that's what the difference is. So there's quite a bit of difference between the upper and the lower. Now, let's see. I guess we'll go down underneath to where all the goodies are. Show you all that. We're going to get down here on the floor. Well, there you go. There's the pump for the summer heater, and this bracket down here below, that's where the winter pump would be. But I had an older pump that wasn't putting out the volume that I would like, and I came across this one here, put that in. I like that a lot. So the winter pump is going to be replaced as soon as I need it. I don't need it right now, so it's not that big a deal. Now, one of the things you got to have on a system like this is a solenoid. Now, I'll tell you the reason for that is because when you hook up a collector loop to, which is going to be, you're going to be connected to the hot and the cold side, it's essentially the same as taking a pipe and just run it directly from hot to cold. So what would happen is when you go to turn on your hot water, the pressure from the system can't differentiate between where the water is coming from. It'll come from the hot and the cold at the same time, but predominantly from the cold side, because there's less resistance on that line than there will be on the hot side, because on the hot side it's got to go through the tank and that creates resistance. So what you'll get when you open up the hot line or the hot spigot on your house is pretty lukewarm to cold water. So that's the reason for the solenoid. That's got to be in there. Then because there's two pumps on here, when the winter, or excuse me, yeah, when the winter pump comes on, what's going to happen is it's pushing enough pressure through the system that it'll want to backflow into the into the summer water heater collector and cause it to lose temperature. So I had to stick on a backflow valve there to defeat that problem. Now the other thing is when you put something like this together, the water that you're going to be sending to the coil always has to come from the cold side. And the reason why that is like I told you before, because the upper part of the tank and the lower part of the tank have two different temperatures. The water stratifies, and the hot water stays on the top and the cold water sinks to the bottom. So on all water heaters, there's a tube on the cold side that goes down at the bottom. So whenever you're putting water into the water heater to fill it back up, it's always going to the bottom. If it didn't have a tube in there, what it would do is it would mix with the hot water and dilute it, and you'd run out of hot water real quick. So that's the reason why they got a tube in there to run down there. So you're sending the coldest water down to the bottom, and you're keeping your hot water up in the top. So that's real important. And then you also want to have some cutoffs on the inside that lead to the outside, because when you open your valve on the outside to drain the system, you got to be able to cut off the water that's feeding that system to begin with. And on top of that, because of bleed through from the cold on the outside, if you didn't do that, you would probably have frozen lines, coming right in at the very part of the wall where the pipe comes through, and they probably freeze up on you, even if you had your shed heated. So anyways, I think that about covers it. I'm going to be doing another video here shortly because I'm expecting my Genitree 6 kW inverter coming in anytime now, and that's going to be a fun project, hooking that up and testing it out and seeing just how hard I can push it. So look forward to that, and thank you all for watching, and I'll see you again soon. Later.